In this video, I want to introduce you to some position function terminology. These are terms that are used over and over again and kind of assume that you already know them because they're not introduced very well all the time. I'm going to stick to one dimension to keep things simple. In one dimension, I have some function which I call x of t. For some time, which I'll say in seconds, this function is going to give me some position along the x-axis. And so here's an example. Technically a vector function of time. It gives me a vector of some magnitude along the x-axis pointing in either the positive or negative direction. So the first thing I want to introduce you to is what I call the initial condition. The initial condition of this function is defined to be the value of the function when time is equal to 0. So the initial condition would be the function evaluated at 0. This is often given its own notation, which I'll call x sub 0. It's referred to as x naught. This is a variable now that represents the value of this function evaluated at the time is equal to 0. For the example we have here above, x evaluated at 0 gives me 20. Often we are interested in 2 points of time, which are not necessarily where the time is equal to 0. We'll call our initial time and our final time. So I'll call my initial time t, and I'll give it a subscript I, meaning it's initial, and my final time, I'll give that a t, and I'll give it a subscript f for final. A lot of times the initial time might be given by t sub 1 for, say, like your first time, and your second time might be t with a subscript 2 for second time. There's no particular notation that's uniform. In fact, as you set up problems, you can use any notation you like. I sort of prefer this initial time and final time. Let's say, for example, if my initial time was 2, and if my final time was 5 seconds, then t sub f would equal to 5. The other thing I want to introduce you to is delta t. When we write delta t, we often mean the time difference between 2 points in time. And so that time difference is going to be t final minus t initial, which in this case would be 3 seconds. If we are interested in some initial and final time, what we're interested in is the positions at those times. We have what we'll call the initial position, which would be the value of our position function evaluated at the initial time. So no, it's not unlike sort of what we have here, where sort of the initial condition. Don't get these completely confused. A lot of times our initial position will be at t is equal to 0, but it's not necessarily always the case. But it's the same idea. I have some initial time, t sub I, and I'm going to evaluate this function at that time, and it's going to give me my initial position. And then I might have some final position, which is going to be this function evaluated at t final. I mean, this is a lot of writing here, and so I might like to use a shorthand notation for that. I often will give that, say, x with a subscript I, and my final position might be an x with a subscript f. So this is now a symbol, but these symbols mean the function x of t evaluated at my initial time, where this means my position function evaluated at my final time. Since these are positions at 2 points in time, we might be interested in the position difference, which I call delta x, which is going to be the final position minus the initial position. If we do this with the example we had before, my initial position, which is x evaluated at my initial time, which is 2. Well, evaluating this at 2 gives me 0. My final position is x evaluated at my final time, which is x5, which is minus 30. And so I have my x final, which is minus 30, minus my x initial, which is 0. And so the position difference is negative 30 meters. It has a magnitude of 30 meters, and it's a vector pointing in the negative x direction.